This is our second lesson on composite shapes, and in this lesson we're going to do some examples of composite shapes and actually calculate the areas. And what I encourage you to do is, whilst watching this screencast, pause once the example has been presented and see if you can actually proceed on your own first, and then play the video or play the screencast and check you're working. Alternatively, you can have a go at solving it. If you get stuck, then play the screencast just to get yourselves unstuck. So that's probably the best way to use this screencast. Anyway, we'll start now. So we're now going to do an example, and here it is. So here's our composite shape, and what we want to do is work out the area that's shaded. The area that's shaded in blue. So if you remember the steps in solving a problem like this, the first thing was to identify what the key shapes are. So pause the video now and see if you can identify them, and then restart to see if you were right. Well, I hope you had a go. So let's now see what the shapes are. This base section here, it looks like it could be part of a rectangle, and that's clearly a rectangle in there. Also, we can hopefully see that there is a semicircle involved as well. So far we've got the area of the rectangle and an area of a semicircle. But in the middle, if you remember, there was a hole. There was a hole in the middle. So there's our hole, which was also another circle. Okay, so what we're going to do is write down the three shapes we need to calculate the area of. So we need to calculate the area of the following shapes. So this is how you'd set your workout. The first one was a rectangle. And we know that the area of a rectangle is its length multiplied by its width. The second shape was a semicircle. And that is the area of half a circle, which is pi r squared divided by 2. Or alternatively, we can write that as a half times pi r squared. The third shape we had to consider was this hole in the middle, which was a full circle. So we've also got a complete circle, and I'll just write circle for that. And that's pi r squared. So what I'm now going to do, I'm going to label each of these shapes. I'm going to give them a letter. That's shape A, shape B, and shape C. And if we draw a little table, and I hope you will use your rulers to do the same, if we draw a little table up, where we want to work out which ones we add together and which ones we subtract, then A and B, we'll just go back, get rid of that one. A, that's shape A, and shape B are added together. So they will be added. And it's this circle in the middle, which is the hole, or the hole punched out in the shape, that's going to be subtracted. So shapes A and B, which are the rectangle and the semicircle, we're going to add those areas together, but then we're going to subtract the area of the circle. So that just reminds us which ones we have to add and which ones we have to subtract. Okay, so let's go ahead and work them out. And once again, I encourage you to pause and do this on your own, and then come back and check you're working. Okay, well, I hope you had a go on your own, but if you didn't, well, I hope you have a go next time. So the area of the rectangle, let's go ahead and work them out. Now, before we can do that, of course, we need some dimensions. So there they are. And let's have a look what we've got here. Well, if we're going to do the rectangle, the area of the rectangle which is shape A, that equals length by width. So, well, we know the width of the rectangle. If you remember, let's go back and have a look. There's our rectangle here in orange. We can see that its width is 8. But what's its length? We don't know its length. Let's have a closer look at this. So, we don't know the length of our rectangle. But let's have a look at this shape here. We know that this is a semicircle. And because the semicircle starts here and ends here, and that's the same, that distance there, that distance across there is the same as the length of our rectangle. Now you might remember that the distance across, the whole distance across that semicircle is the diameter. Of the semicircle. And that also, we look at this diagram, we can also see that that distance there from here to here, that distance there is the radius of our semicircle. So there's the radius of our semicircle, that dimension there. And of course we also know that the diameter is twice the size of the radius. So let's just write that down, that's important. The diameter is always equal to twice the radius. So our radius of our semicircle, the radius from the centre to the outside, is that distance there, which is from here to here. Now, that distance there, we don't know that distance, but we know that from here to here is 18. And we know that this length here is 8. So this section in here must be 10. So the radius of our semicircle from there to there must be 10 centimetres, which means that our diameter must be 2 times 10, which is 20. So the diameter of this large circle is 20 centimetres, which is the length of our rectangle. So sometimes the measurements are hidden and you have to actually have a close look and see if you can actually work out what the missing measurements are. So now we can work out the area of our rectangle. It is, the area of the rectangle is going to equal 20, which is the length, times 8, which equals 80, my apologies, not 80, 160 centimetres squared. So there's the area of our rectangle. So let's put that in our little table. So the area of the rectangle was 160. There it is there. Okay, let's go back to our original diagram. Okay, so I've done the area of the rectangle. Now we can do the area of the semicircle, which is this part here. So we'll do the area of the semicircle now. I'll do it in a different colour. Area of semicircle. And that equals pi r squared divided by 2. Now we need to know what the radius of that semicircle is. Well, as it happened, we worked that out just a moment ago. The radius is from the centre to the outside, that distance there, which is the same as that distance there, which was 10 centimetres. So the radius is 10 centimetres. So r equals 10. So let's go ahead and work out the area. It's going to be 3.14, which is the value for pi, times r squared. It's going to be 10 squared divided by 2. And that will equal 3.14 times 100 divided by 2. And therefore, that will be 314 divided by 2, which will be 157. So the answer to that section there, that equals 157 centimetres squared. So that's the area of our semicircle, this part in here. So let's now go back and put that into our table. So it's 157. That was shape B, which was our semicircle. Now the final shape is the circle. And the circle is a full circle. Do we know its radius? Well, let's have a closer look. We know that the radius of our small circle is from there to there. Now, that distance from there to there is the same as the distance from here to here. So that distance there is also equal to the radius. Now, we know that from that section to there is 8 centimetres. And we know that from here to here is 3, so that distance there is 3. So this distance here must be 5, because both of these must add up to 8. So we can now see that the radius of our small circle is 5 centimetres. And so, we'll just give ourselves a bit more room here, I think. And so the area of the small circle is going to equal pi r squared, where the radius is 5 centimetres. There it is there. The radius of our small circle is 5 centimetres. So I'll just write that down. R equals 5. So let's work this out. It's going to be 3.14 multiplied by the radius squared, so it's going to be multiplied by 5 squared. So it's going to be 3.14 multiplied by 25. And if we work that out, that will equal 3.14 multiplied by 25, and the answer is 78.5. So that equals 78.5 centimetres squared. So that's the area of the whole. And remember, because it's a whole, it's going to go in the subtract column. So that is going to be 100, oh sorry. Actually, I might zoom back in again. So C is going to be, oh, I forgot what it was now. 78.5, yep. Okay. 78.5. So they're the three calculations we had to do. So the final step is to now work out the total area. So we need to add the ones in the addition column and then subtract the value in the subtraction column. So the total area of our composite shape, the blue shaded area in other words, the area of our composite shape you need to make sure you conclude with a statement like this, is equal to 160 plus 157 subtract 78.5. And so that's going to be 160 plus 157 minus 78.5, and that will equal 238.5 equals 238.5 centimetres, because all our measurements are in centimetres, squared. So there is our final answer. Now, just a couple of points I'd like to make. This problem, and these problems in general, as I'm sure you will now see, require a fair bit of working out. So there's the working for one problem. And so it is now absolutely critical that you start setting out your working, if you haven't already done so, in a very methodical manner. So you need to show the separate calculations for each part, make use of headings and subheadings. So, for example, you'll notice here I used headings. So you make sure you use headings as well, so that when you go back and look at your work, you know what the calculation is. If you just had this calculation here, if you just wrote this last step here and nothing else, for example, when you're working out the area of the small circle, when it comes to actually working it out at the end, you will forget what that value stood for. So you need to have the working showing how you got there, but you also need to use a subheading to tell you what that calculation represents. Here we used a subheading to actually tell us and remind us what the calculation is for. I cannot emphasize this strongly enough. You must show your working, you must use subheadings. And then this little table at the end, you can put your final answers in this table and quite easily work out your final answer. And if you actually use this sort of method to set your working out, I would expect you'll get virtually every problem correct, okay? Because often where people go wrong is that they lose track of where they are in the calculation because they've substituted in the wrong number because they got their working out mixed up because it wasn't organised. Okay, so in our next lesson we're going to look at another example of working out the area of a composite shape.